The first part of this problem is fairly straightforward. Remember the formula that the heat absorbed is equal to the mass of the substance multiplied by the specific heat multiplied by the change in temperature. So the mass of the substance is going to be 1 kilogram because it's 1 liter of water, and remember that 1 liter of water has a mass of 1 kilogram. So that's 1 kilogram multiplied by the specific heat, and the specific heat of water is 4,186 joules per kilogram degrees Celsius, multiplied by the change in temperature, and we're going from 20 degrees Celsius to 100 degrees Celsius, so final temperature minus the initial, 100 degrees minus 80 degrees. And if we put that into a calculator, then we find an absorbed heat of about 3.349 times 10 to the power of 5 joules, which the answer rounds to about 3.3 times 10 to the power of 5 joules. So that's part A. And part B asks for how long this amount of energy could run a 60-watt light bulb. Now remember that when we talk about wattage, we're talking about power, which is equivalent to, power is defined as the rate of change of energy. So a change in energy divided by a change in time is what the power is. And when that change in energy is specifically referring to heat that is being absorbed by an object, then that is equivalent to our Q, the answer that we found for part A. So what this part of the problem is really asking is how much time it would take for the amount of energy we just found to be absorbed. This means that we're going to have to algebraically rewrite this equation to solve for delta T. So if P is equal to Q divided by delta T, then we multiply both sides by delta T, and we divide both sides by P. It's pretty simple algebra, and it tells us that the time interval is equal to the heat absorbed divided by the power. So that time is equal to the energy we found in the previous part of the problem, so 3.349 times 10 to the power of 5 joules, all divided by the power given as 60 watts. And if we put this into a calculator, then we find a time of about 5,600 seconds. And I'm not sure whether the problem wants seconds or minutes, so if you divide this by 60, then we find that another way to write the answer is 93 minutes. So that is the answer to this problem. I hope this video helped you out. If it did, please consider subscribing or donating to my Patreon, as that'll help me out in making more videos just like this. If you have a request or a question, leave a comment down below, and I hope you all have a lovely day. Bye-bye.